Congratulations.
Hey, Brennan.
Good
Hope
job.
you watch this. Good job.
Good job, man.
Okay.
That was like the best equation.
All right. The ASVAB, to get into the Army or a branch of the service, it doesn't have to be the Army, but it's their military test. All right. Conics, remember, this is just yet another slide I found with cute little graphic on conics. I did kind of like how it talked through these. It says circle is when you cut straight through, ellipse is at a slight angle, parabola is when it cuts through parallel to the slant height, okay, or the edge of the cone, and hyperbola is when it cuts through a steep angle and therefore is cutting through both cones. Did I just say parabola? That was hyperbola. See, I say them wrong. I tried to get a video for you guys on YouTube. First of all, they're all very slow. Actually, I do have a little tiny clip today, but they're so slow. I just can't even watch them. I don't. And then the one I found that was short, the guy kept going, "Oh, no, parabola. No, I mean hyperbola." And I'm like, I can do that good. So we did actually hyperbolas this year already. You probably just don't remember. When we did y equals 1 over x in the rational function chapter, remember when we had asymptotes? Does that sound familiar when we did asymptotes? Okay. We did things like, this is your basic graph where you have things here, and then we would have like a +5, and we'd go, yeah, that would shift it up 5, and it moved the asymptotes around. Okay, so we're going to review really fast. I don't know if you have this. I think you do. The equation for the vertical and horizontal asymptote for each one of these. Anybody help me out? Number 1, vertical asymptote. Vertical's this way, so it's the y-axis, so its equation is x equals 0. Because all the points on it are like 0, 0.5, 0, 2, all the x's are 0. That's why that's the equation of the y-axis, okay? The horizontal is the one going this way. It's the y-axis, so that is y equals 0. Did I just say that backwards? It's the x-axis. That's what I said backwards. Okay, I'm feeling the need to start over the taping already. Okay, it is a horizontal line. It is called the x-axis. Its equation is y equals 0. Try again. Number 2. Vertical is this up and down one, which has an equation of x equals 3. Horizontal is y equals 0 again, the x-axis. Number 3. Vertical, x equals what? -3, and horizontal? I think it's supposed to be 2, isn't it? The red line is at 2. Everybody good? Okay. Our asymptotes today are going to be oblique. Does anybody remember what that means? Slanted? Slanted? Okay, slant asymptotes. We'll talk more about those in just a second. There was nothing else down below that, was there? Okay. This is a picture again. I don't know why I put that on there. A hyperbola, the definition is when a plane is parallel to the axis of a double cone, slices the double cone in a conic section called the hyperbola. Hyperbola has 2 foci. Okay, we'll talk about them, but the foci are inside these little curves. Okay, has 2 vertices. The vertices will be the point where those change from like increasing to decreasing. True or false? The graph of a hyperbola consists of only one curve. Anybody? False. 2 curves. So right there, 2 curves. Hyperbola is not a conic section. False, it is a conic section. A hyperbola has 2 vertices and 2 foci. True. Okay, they're true-false questions. Aren't very exciting. Okay, I'm going to jump around in the notes a little bit, so I hope you took out all the worksheets I asked you to at the beginning. This is the definition of a hyperbola. And it's not as easy. Remember yesterday's little string experiment? That was fun and easy to understand, right? This is more complicated. It says a hyperbola is formed when you have two foci. The foci are going to be over here at C and the opposite of C, okay? And the definition is the set of all points such that the absolute value of the distance from any point on the hyperbola to one foci and from that point to the other foci is always a constant. Distance means we subtract. Is everybody good with that? Find the distance between 2 points you're subtracting. So if I pick a magical point here and I measure the distance to this focus point and the distance to this focus point and I subtract those two numbers, I'll get a constant. We'll just call it K, okay? If I go over here, they did one, I thought they did this. No, they didn't? Oh, here, they did it in blue. Sorry, I'm apparently blind. They picked this point right over here, and they measured to this foci and this foci, and they subtracted, and that would be the exact same constant as my green points, okay? And it's very confusing. It's not something I grasp like I do the one on the backboard where you take the string, right? It's not a definition I'm going to ask you to repeat on a test or quiz, okay? But this constant value that we get is also, by definition, twice the distance from this vertex to the center here. Or it's actually the total distance between these two vertices. Okay, so that little purple line, that constant value, is the difference between any point we would pick, the distance to the two foci we subtract, we'd get that purple line. Okay, yep, that's kind of how I feel about it too, that blank look like you have on your face. Okay, that was my attempt to sketch it out. We won't even go there. Okay, this is a vertical hyperbola and an example, okay? So here is a cone, or actually there's several different cones of light coming out here, right? This is a hyperbola. This is a hyperbola that has what we're going to learn later would be a different eccentricity, means a different stretch to it, okay? Those are vertical hyperbolas, meaning they open up and down. The axis that runs through the middle is a vertical line. So basically an axis of symmetry, but it's called the transverse axis, the one that runs through the middle there. So in this case, it is the y-axis. Okay, I need you to notice this equation. It has y squared over something minus, okay, x squared over something. Two things are important. The minus makes it into a hyperbola. Is everybody okay with that? And the fact that the y squared came first meant it was opening its little cones around the y-axis, up and down. Okay? Because look what happens when we switch to the horizontal parabola. It's still a minus, but what came first was what? The x squared is positive. The x squared tells us, the positive x squared tells us it's opening around the x direction. Transverse axis is the x-axis in this case. It is a horizontal hyperbola. Here's another picture showing where there's hyperbolas in real life. Buildings that use this hyperbola shape are extremely structurally strong. That's the reason they're used for things like a nuclear power plant. Also, is it called Kobe Tower in Japan? Has that shape? I think the next slide might have the little, okay, this is cool. This is sound waves. If you have two sources of sound, the interference between the two forms hyperbola here. I tried to outline the one in yellow. Okay, this is our video entertainment for the day. It's very short.
It has two asymptotes where the hyperbola comes. Hyperbola, great it is. Hyperbola, yeah, great it is. It has two parts. It's so fabulous. On the XY axis, on the XY axis, from up there to down below. Why isn't it continuous? At the Y axis, outrageous.
This is cool. There's gears made in that look like this.
Y is K on X-ray.
They put two of these against each other, and you can have axes that aren't perpendicular.
Fill it out. Come on, baby, it's hyper.
Anybody in physics do this kind of stuff with? Do they talk about the shape of lenses? Nice how it's cut off at the top there.
Hyperbola, great it is. Hyperbola, yeah, great it is. It has two parts. It's so fabulous. On the XY axis, on the XY axis. I've told you before, a million times before.
That's Kobe Tower in Japan. It's cut off at the top, but this is kind of cool. Watch that thing spin and see if you spot the hyperbolas on the side. Okay, so that was a bit annoying, but it was our little break for the day, okay? Just a real quick slide here. This is different conics, okay? This is an elliptical mirror to show that reflecting light off, if you aim it from one focus and hit the elliptical mirror, it will always land at the other focus. I think there's also, it may be that's used, has anybody ever been where there's like one of those whisper chambers where like you're supposed to be able to stand anywhere in the room and or stand in one place and somebody at a particular spot can hear you across the room? I think that has to do with a elliptical shape as well. These are hyperbolic mirrors, and they're used, both elliptical and hyperbolic things are used in telescopes, and I don't understand all this, so I'm just going on, okay? All right, this is the shape that we're going to talk about. Do you see that gray rectangle drawn in there? Okay. Yes. Oh, thank you. Did I manage to? Okay, nice. I don't know when I stopped that. I think I maybe only missed this slide because it was at like 10 minutes or something. So we'll go with I didn't miss anything too important, just the video. All right, we're gonna start here though. This is important concept. This rectangle is gonna be important to us. It's called an auxiliary rectangle, and I spelled this wrong twice this morning trying to write a slide. I think it's spelled like that. I'm not positive. Is anybody good at spelling?
I think Ben's right.
Where?
That's a W, right? Or
No, A-U-X-I.
Okay,
Sorry,
no,
that's my bad handwriting. Sorry. It's called auxiliary rectangle, and it's important because if this distance on our picture is 3, okay, in the x direction, that meant we had an x squared over a 3 squared. That's how far we went out. And then it's opening around the x-axis, so I know that the x came positive. I'd have a y squared over up and down. It went how far? 2. This would be a 2 squared. So the equation that they're showing is this. We're going to do some of these in just a second. But the important thing I wanted to talk about, let me see if I can grab my line tool here. Of course, and I can't. All right, I'll fake it. Oh, here's some arrows. Can I just do that? Will it let me grab that or not? Nope. Okay. that horrible diagonal of the rectangle and this horrible diagonal are what to those curves? Does anybody notice what they're doing? They are the asymptotes to the curves. Do you see that? Badly drawn. Okay. The equations of those so we're going to draw that little rectangle so that then we can put in the diagonals, and those will be our asymptotes. The equation is going to be, this goes through the origin, and it went up 2 and over 3. Does everybody see that for the slope? So it'll be y equals 2/3 x. This one going the other direction. What do you think? Anybody figure out the slope of that one? Making me sad. What is the slope of this badly drawn line? Yeah, isn't it just doing the same thing but in a negative direction? Thank you, Ben. Y equals negative 2/3 x. Okay? When we've put those asymptotes in there, then we're going to talk about how to find C in a second here, the focus point. But those asymptotes and their equations, I need you to see where something is coming from. Even when we switch this around, slope is always y over x, right? Everybody with me? Slope is going to be the number under the y over the number under the x. Got to square root them, but okay. Even when we switch the order around, it's going to be y over x. Then we're going to find C, and we'll talk about that in just one second. I want to go on to the next slide here so you guys are actually doing something. You guys have this. You can use this. It's also copied on your orange reference sheet. But I would like to jump to worksheet 10 and go through just a couple things, and then we're going to do an example on worksheet 11. So we're going to talk about 10A and then 11A, I believe. All right, on 10A, it says up in the corner that this is a reference sheet. Unfortunately, it's not what I'm going to let you use on the test or quiz. You have plenty of other stuff on the orange reference sheet. Sorry, let me turn that sound off. Today, all of the hyperbolas we're going to graph are centered at the origin. Next week, we're going to do ones that are slid all over the place for great entertainment. Again, this is called the auxiliary rectangle. If it starts with a positive x squared, it's going to open sideways, and it's going to be called, which kind? Okay, this is the transverse axis, and it is a horizontal line, so this is called a horizontal hyperbola. Anybody awake out there? Okay. The foci, I said I was going to get to that. You locate the foci by, it's going to be called C, but the formula we use, is this the same we used yesterday for an ellipse? C squared equals A squared plus B squared. No. This is the way I keep it straight, okay? Two things you can do to remember this. First of all, the focus point is going to be inside the curve, so it's further away from the center, so you have to add these, if that makes sense to anybody. The other thing is, when it's an ellipse, this was a plus, right? And the sign to find the focus was a minus. When this is a minus, it's a hyperbola, and the sign to find the focus is a plus. You guys get to use the reference sheet, so you'll always have it anyway, but just a way to help you remember when you're doing your homework quickly. They're the opposite signs. All right, so we're going to do an example in 1 second. The two dashed lines are the asymptotes, okay? It says the asymptotes are the diagonals of a quadrilateral whose dimensions are 2A, so it goes out A either way here and B either way here, so 2B would be the dimensions of that rectangle. All right, one quick slide here to show what's the difference. What's this slide talking about? Nobody can tell me what's different on this one than the last one?
Vertical.
Okay, thank you. Pearson's looking, right? This has a transverse axis that goes this way, which is vertically, and therefore it is a vertical hyperbola, and I know that from looking at the equation y. Y as in WHY, but the y is because the y is the positive, okay? Ready, okay? It says the equations for hyperbolas and ellipses are identical except for the minus sign. In graphing either, the positive axis variable x or y is the axis which contains the vertex and the foci. So if this is the positive one in a hyperbola, that's where the vertices and foci are going to be. All right, let's just jump into doing one of these. Worksheet 11A. I think it'll make a lot more sense if you just do one. If you're picky about drawing straight lines, there are rulers on the wall, but I'm just going to get started here. I believe your worksheet says you need the equations of the asymptotes. Does it say that on yours? Did I write that at the top for you? Okay. Pick the horizontal one out of these two. Which one of these is horizontal? Okay. Horizontal means the axis that runs through it is running horizontally, so it's opening sideways. Which one is opening sideways? 1. Yes, because it's got a positive x. Everybody okay? The x being positive means this one is horizontal. All right, so let's start with number 1. I'm going to use a different scale. Can we count by 2s? Because otherwise it's not even going to come close to fitting. Okay? Does anybody know how far out I have to go on the x? Yes. That's a squared, so a is going to be 5. So 2, 4, 5. 2, 4, 5. Those are called what? Anybody get what those were called? Right here. Vertex. Okay, the vertices are at plus or minus 5, 0. Now, to draw this accurately, we need the other 2 points on the y-axis, which are only part of the auxiliary rectangle. They're not actually part of the picture. But how far does our rectangle go up on the y? So 2, 4, 6, 7. 2, 4, 6, 7. And that's going to help us draw this, but honestly, it's not part of the hyperbola itself. I don't know. I'm going to attempt to do my rectangle here. I don't know. I'm not sure how this works. There we go. Okay, can you draw the rectangle that goes through those points? Can you kind of see mine or not? Is yellow a bad color? Unfortunately, I need my line tool. Can I make this bigger? Or not when it's going? All right, I can see my line tool anyway now. All right, I am going to draw in the asymptotes with some dashed lines here. Okay, and then I can draw in my actual hyperbola. What is the big deal about the hyperbola? What shape is it? It's a curve that goes through this vertex point and gets closer and closer to these asymptotes as it goes further out here. It doesn't actually touch them. Okay? And I'm sure I'm doing a really bad job. All right, did I totally lose anybody so far? All right, the tricky business is finding the asymptotes and the foci. The foci are located inside, so they are on the x-axis. They're going to be C0. How do we find C? Plus B squared, okay? A squared is actually 25, and B squared is 49. So C squared is 74, so C is the square root of 74, which is, just so we can graph it, 8.6. Awesome. So 7, 8, 8.6, whoa, no, half power, wrong axis. I didn't just do that. Going this way, 5, 6, 7, 8.6 would be in here somewhere. It's square root of 74, 0. And over here, 5, 6, 7, 8, 8.6 would be over here somewhere at negative square root of 74, 0. Okay, those are the foci. Okay, so you don't have to, remember we had yesterday vertices, co-vertices, and foci. You only have vertices and foci, but you also have to have an asymptote. I need the equation of those asymptotes. Any help there? They go through the origin, so there's no left-right shift, so there's just y equals x, but I need a slope in there. What is the slope? It went up how much and over how much? Went up 7 and over 5. And one is positive and one is negative. This one has an equation y equals 7/5 x. And this one has an equation y equals negative 7/5 x. Look up here, guys. Even if you never drew it, could you find the slope? Slope, remember, is y over x. So it's whatever underneath the y divided by whatever underneath the x. You got to square root them to find a and b, but okay. Look at 2 and 3. I'm going to do one more with you. Can you pick one that would be vertical? Or 3 and 4? Sorry. Sorry. 3 and 4. I just wanted a new slide so that I could have more room. Which one of these two is? This one is vertical because the y squared comes first. Everybody okay? We do this one? We probably have to count by 2s again, because I don't think we can go out 6 on the y, can we? Or do we want to try? Count by 2s? Okay. So on the y, where are the vertices? Okay. The actual vertices, yes, we need points at 6 and 3 on the different axes, but the actual vertices are the ones underneath the y here, so they're going to be at 0 plus or minus 6, because it's going to open up and down. 2, 4, 6. And was out 3 in the y direction, which will help us with the slope and with the rectangle. I don't know. I can only have either my line tool or my rectangle tool showing, apparently. If I try to draw my rectangle using a line tool, something like that. The only reason we draw the rectangle at all is because the diagonals of that rectangle are the asymptotes. Did you have a question? There is something we need to remember to cross off the homework tonight. Is that what you're looking at? Yes, help me remember that in a second. All right. Which way does this particular one open, guys? Yes, it opens around the y, so this vertex right here at 0, 6 is where it will touch and get closer to those asymptotes. And down here, I'm just gonna do a really sloppy job, okay? It gets closer but doesn't touch the asymptotes. I'm just tired of being careful. Are we okay? What do we not have down? Foci? How do we find the foci? So 36 plus 9 equals c squared. So c is 3 square roots of 5. So is it 0 comma that or that comma 0? Yes, they are inside those curves, so therefore they're on the y-axis. So it's 0 plus or minus 3 square roots of 5. I don't know. It was the square root of 45. That's almost 7, right? 49 would be 7. Yes, they are barely inside, but they are inside. That's a good question, okay? It has to do with how skinny it is. If they're close inside, then it's a skinnier, narrower, okay? If we took these same numbers and made it go sideways this way, because our rectangle is longer that way, the foci would be further inside. All right. Any further? Oh, I forgot one thing. Asymptotes. What do I need to do? Y equals plus or minus up over square root of this, the y over the x, so it's 6 over 3, which is 2. Okay, the asymptotes are at y equals plus or minus a over b or b over a x. In our case, a is the one underneath the y, so it was a over b. Change in y over change in x. That's just the way I remember it. Slope. All right. What do you have to do first on these? I'm not going to do any more, but what would you have to do first? Divide everything, okay? So like on this one, you divide everything by 64. So you'd have y squared over 64 minus 16 goes into 64 4 times. And then you could graph it. Are we better? Everybody remembers those? Okay. I'm going to jump back to this. I thought I put a page. Oh, back to worksheet 9. It says 9B. Problem 1. I wanted us to graph a couple before they start right in with they start right in with write an equation. What is the standard form equation of a hyperbola whose vertices are at 0, 4 and foci are at 0, 5? You guys know I can't do these without drawing, so I'm going to do a little tiny sketch over here. If the vertices go over 0 and up 4 and down 4, what kind of a parabola or hyperbola is this? It is opening vertically. I don't know what it looks like exactly, how wide or skinny. But what does that mean in terms of writing the equation? The y squared has to come first, right? Everybody okay with that? Because the vertices are on the y-axis. All right. The foci are at 5. That'll help us find the a and b, one of which we already know. If the vertex was at 4, then a is 4. The foci are at 5, so that means c is 5. So how are we going to find a? C squared equals a squared plus b squared. We went up 4 to get the vertices, so that's 4 squared or 16. Plus b squared is equal to 5 squared. 25 minus 16 is? We're working backwards, so we have to subtract. You all right, Jim? Got it? So it's 3, 4, 5. So it is a 3. So B is 3. So if I needed to actually draw in the rectangle, it would go out 3 this way. Okay? And I could find the equations of those asymptotes if I needed to. Can anybody tell me what they... Well, let's write the equation first. All right. So the y, we went up and down 4. So this would be 16. And underneath the x squared would be? How far did we go out on the y? 9. The 25 was when we added them together and got the foci. Yep. Okay. It says simplify. Oh, they must meant square them. I'm good. We squared them already. We're good. We're just that good. We jumped ahead. Can you tell me the asymptotes just for practice? Anybody know what the equation would be? How far is it going up and over? Oh, be careful. It went up 4 and out 3. I'm not sure what you said, Sam. Maybe. I don't know if you were thinking about the numbers from the last one, but. Okay. So it went up 4 and over 3. Everybody okay? And this one would be down 4 and over 3. All right. Oh, this is on your reference sheet. I can't ever do anything in order. This is on the orange reference sheet. Everybody have it somewhere? This is when it's at the origin. It gives you the information. There's actually another slide. This one is also on there, right? It goes through the form. Everything is spelled out very clearly there. But I want to talk about these properties down here. Can we read through these real fast? See if there's any of these that don't make sense to you. The hyperbola bends towards the foci. Does that make sense? Okay. The positive term determines which way it opens. We're good with that. The distance between the foci is 2c. So the foci are from the center out c on either side. So if you measured from one foci to the other, it'd be 2c. The distance between the vertices is 2a, because they are a away from the center. The center is the midpoint between the foci or the midpoint between the vertices. And to find c, we would do c squared equals a squared plus b squared. Right, all those properties make sense? I have a little arrow here because there's something underneath here. What's that say? When the equation is in standard form with the x term positive and the y term negative, it will open left and right. Okay. Is all this on your reference sheet? So it spells out everything, right? And you get to use this on a test or quiz. All right. You don't have this one, but I feel like we've kind of done enough. Do we need to do another one? Let's do this one instead because it wants us to graph it on the calculator. I feel like these are numbers we've already done, but let's do it anyway. What would you have to do first? I want us to graph it and then we're going to graph it on the calculator. You would divide everything by 36. Don't even, if you don't want to write this down, don't. Just help me, quick. Ah! Okay, forget it. The bell's going to ring. I'm going to skip this one. Oh, well then why are you all packing up? You're making noises like you're all packing up. Okay, 4 goes into 36 9 times. You know my usual. I don't know what time this class gets over. Y squared over 4 equals 1. Which way does this one open? Yes, it opens this way. And where are those vertices at? The vertices are on the x. How far over? -3, 0, and 3, 0. And if I were to draw in the rectangle, how far up and down would it go?
2 down.
2 up and 2 down. And to find the foci, you add those, right? Which is 13, so they are at plus or minus square root of 13, 0. And to find the asymptotes, y equals, be careful, square root of this, y over x, so it's 2/3 plus or minus 2/3 x, the number under y, number under x. How would we get this in y equals form? We'd have negative 9y squared equals 36 minus 4x squared. We'd have to divide by negative 9. And then we'd have to square root, and if we were typing it into y1 and y2, yep, we'd have to do the square root of 36 minus 4x squared over negative 9, all in the square root, and then negative square root of 36 minus 4x squared all over negative 9. What's the website that would be much faster? Desmos.com. Okay. Moving. Do you need me to do this on the calculator, or you got it? Did anybody actually type it in? Did it work? Yep. Okay. Shh. I want to finish 10B. You told me I have 5 minutes, so I'm finishing 10B. I feel like we just did the same question practically. X squared over 4 minus y squared over 9 equals 36. Okay, circle all the true statements. What's true? Transverse axis goes which way? Transverse axis means the one that goes through the vertices. Is it a horizontal or vertical hyperbola? Oh, equals 1, yes. I'm sorry. Yes, thank you. It equals 1 there. I was like, what are you talking about? No, sorry. Shh. Please? Okay. This is a horizontal. The transverse axis is the one that goes through the vertices, so it is horizontal. The vertices are not on the y-axis. They are on the x-axis. The foci are then also on the x-axis. The vertices are how far out on the x? Plus or minus 2. The foci are at, add 4 and 9, so we get square root of 13. The slopes are b over a, which is the number under y over the number under x, 3 over 2. So plus or minus 3/2 x. Okay, sketch it. I want to walk around and see everybody has done this. This is 10B. And then answer the question at the bottom. Okay, what's going on here? It says circle the one that's vertical. Which one is vertical? Okay, underline the horizontal one. Name one way that the two equations differ. One's vertical, one's horizontal. One has a positive y squared, one has a positive x squared. Okay, I don't care if you write anything down, it's your notes, but I just want to know that you understand the difference.